it, and boom, all your irrational numbers disappeared. You know how to get back there and do it exactly. Okay? So, let's move on. The next question, if you're getting the hang of this, which I hope you are, try this one and see how you do with it. There's maybe one extra step that you're going to have to think through it before you come up with your integrals. Okay, so I'll do my best to put a reasonable picture on the graph. I'm not promising anything earth-shattering, I guess, for accuracy here, but kind of goes like this, and then down through here, and sort of back up, and then I end up with the parabola that kind of does this. That's not bad, actually. Just getting warmed up. Okay. So what you should notice in this picture is there are now two regions. So there's not only one place to look, there is another. So we're going to need two integrals to calculate the area between these curves. So let's, before we can get these integrals set up, we need to know the bounds. So, it is possible to solve this one. And I'll do that quickly in the margin here. So 3x cubed minus x squared minus 10x equals this side. Negative x squareds will disappear. 3x cubed minus 12x equals 0. So 3x x squared minus 4. So x plus 2, x minus 2. I end up with my bounds at x equals 0, negative 2, and 2, which are these points here. Okay. So that means I can come up with my bounds. So let's work on area number 1. It is the integral from negative 2 to 0, and it's the cubic which is on top. So this cubic graph is the first one. So it'll be x cubed, I forget what the cubic one is now, minus x squared minus 10x. So there's a minus x squared minus 10x. Folks, don't you go to sleep. There we go. Technical difficulties. And we subtract the parabola, which was negative x squared plus 2x. So again, the x squareds will disappear, and I'll end up with an integral from negative 2 to 0 of 3x cubed, and oh no. Hopefully that's the end of it. 3x cubed minus 12x. So when I take the integral, it's going to be 3x4 over 4 minus, that'll be 6x squared from negative 2 to 0, which I believe is 12 if you put those values into your calculator. Okay. So we need to work out region number 2, which will be very similar, except in region number 2, it's the parabola which is on top now. So here I now have a parabola on top. So I need to switch the two functions around. They're going to get switched when I take the integral. So this time I go from 0 to 2, and the parabola is on top. So negative x squared plus 2x minus 3x cubed minus x squared minus 10x. So the negative x squareds will cancel out, and I'll be left with the integral from 0 to 2 of negative 3x cubed, and I'll have minus 12x. And this is going to be the integral I take, which will be negative positive, I believe. That should be positive 12x. So it'll be negative 3x to the 4 over 4 plus 6x squared from 0 to 2. And I believe it also is 12 when we put them together. So area 1 plus area number 2 is 24. And that would be the answer for the region that's bounded for these two curves here. 12 here, 12 here, a total of 24. So I'll leave it down here in case you need to copy anything else.